Okay, we are back. We are back. Algebra 1. We are back. 7.3b, rational exponents. So there's a second part of section 7.3b. Today we're going to solve equations involving the rational exponents. So first to do that, let's talk about an exponential equation, what it is. An exponential equation is an equation in which the variables are in the exponents. So, for example, you might see something like 7 to the x power equals 243, okay? And in this case, we know that this part here is the exponent. So in this, our variable is in the exponent. So we can solve those, all right? The power property of equality, what does this mean? What do we do? So if I'm going to solve something like this, if you make the bases the same value, you can solve the equation from the exponents. So as long as your bases are the same, then we can solve an equation with the exponents, and it'd be no problem. An example would be if b to the x power equals b to the y, then x would equal y. That's our example there. Okay, another example would be the example we used on the first page there, 7 to the x equals 243. Okay, and as keep that alive when we think about it. But one example would be if we had, I can move this whole thing. An example here, 5 to the x equals 5 to the third power. Because the bases are the same, in this case 5 and 5, then we can solve the exponents. The exponents have to be equal. So because like here, this would be 5 and 5, then our exponents, x and y, would have to be equal. So x here and 3 would have to be equal, and so we could easily solve that x equals 3. That's pretty simple. Okay, they do get a little more difficult than that, but that's a really easy example. And we'll take a look at this example here, 7 to the x. Well, what is 7 to the, what is 243? Well, in this case, we'd have to write, again, the base is the same value, so we have to write the bases to be the same here. So in this case, I believe this is 7 to the third power. So again, our bases are the same, so we could have x equals 3 again. It's not always going to be x equals 3, it just kind of worked out that way. Okay, so to solve an exponential equation, first thing we're going to do is we're going to rewrite the equation so that you have the common bases. So just like we did here, we rewrote the 243 in terms of 7 as our base, and that way we could solve it. So that's the first thing we're going to do is rewrite the equation so we have common bases. The next thing we're going to do is set exponent equal to exponent, and then we're going to solve for the variable if it's necessary. Like in our examples we just did, it wasn't necessary because we already had x equals something. But here, we can solve for it. All right, so let's do a few of these big problems, example problems. So 2 to the x equals 64. Okay, so the big thing is down here, we just got to kind of decide. We know it's going to be 2 to the x here. But over here, it's going to be 2 to the something, because we want to rewrite it so we have the same base. So if you can do it in your calculator, great. If you know it offhand, that's great. If not, we can always write it out and multiply 2 times 2. So 2 to what power equals 64? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and then another 2 here would give us 64. So 1, 2, 3, 4, 5, 6 of them. So it would be actually 2 to the 6th power here. We said 2 times 2 times 2 times 2, 6 times equals 64. So now we're ready to go. We can get rid of these and set our exponents equal to each other. X equals 6, and we're done. Simple as that. Okay. Let's look at number 2 because it's a little bit differently. Now we don't have to. We're going to have to do some solving afterwards. So we've got 3 equals x plus, or 3 to the x plus 1. We know that. And then we're going to have to get a 3 to something here because we know we want to have the base numbers the same. So we have to figure out what is it. Some of you guys might know that in your calculator. Others, let's go ahead and multiply it out. 3 times 3, well, that's equal to 9, times another 3. 9 times 3 is 27. And then another 3, 27 times 3 is our 81. So in this case, it would be 1, 2, 3, 4. So to the 4th power. So now I've got 3 to the x plus 1 equals 3 to the 4th power. Again, here I can get rid of the base numbers and just focus on the exponents now. So now I've got x plus 1 equals 4. So I can set the exponents equal to each other. And I'm pretty sure with all the work you guys have done in solving equations, you know that this would be x equals 3. Okay? A lot of 3's in that problem. A lot of 3's today. But in that case, you had to do a little bit of solving. Look at number 3. We're going to have to do something similar. Change this 32 into a base number of 2, 2 to the something power. Figure that out. And away you go. All right, let's go here. And let's just do number 5 here. And then we can call it a day because we got a lot of action here. So again, we want to change the base number. So it's already kind of given to us. We know that we're going to use 6 eventually. So 6 to the 3x plus 2. And over here we got 216. So how can we break that down? So in this case, we're going to go 6 times 6 is 36. And then 36 times 6 would equal our 216. So that means we went 6 to the 1 to 3rd power. So up here we can write our 6 to the 3rd power because that's equal to the 216 that we have there and there. And now I'm in a situation where I can go ahead and solve. I can get rid of these 6's and just focus on the exponents. Put them equal to each other. So I've got 3 equals 3x plus 2. So solving equations, we would know that I would subtract 2 first from both sides. So now I have 3x equals 1. And then I'd have to divide here by 3. And so now x would be equal to 1/3. Okay? So I plug the 1/3 up in here, I would get a true statement. Okay, we're going to save number 6 because we got a fraction to exponent, parentheses, and all that junk, and we will work with that in a little bit. See how we can work on that one. Bring your questions. See if you have anything else to do. That's about it for this section. Okay. So our lesson summary: according to the power property of equality, if 3 to the 4th power equals 3 to the x power, then what is the value of x? Should be able to figure that out pretty easily. And here we're going to solve 3 to the 3x plus 1 power equals 81. And that's very similar to number 2 if you look at it. That should help you out a little bit with that one, but solve that problem. Okay, that's it for section 7.3b. Bring your questions. We'll see you tomorrow.